Welcome, Mirco. Well, first of all, congratulations. You just handed in your PhD dissertation. Uh, can you name the topic?
Yeah, hi Chris. I'm very pleased to be here. Yeah, the PhD dissertation was a summary of my research activity in the last few years, which was based on motorcycle dynamics and rider behavior, especially in relation to their interaction with the vehicle. So it's a big, let's say, step in my life, and many things which I learned, like the skills I gathered, really transfer to similar fields, like in analyzing Formula One telemetries, and also they will be useful to show you a couple things we jump today here.
Yeah, and on that note, you have a sizable following on social media in your formula data analysis. Can you tell me a little about what you do there?
Yeah, it's a social media page which focuses on analyzing Formula One telemetries and lap time data to gather additional information on each race weekend. People are really enjoying, and the following shows it, the fact that they are now able to go more in depth inside the race and not only look at the overtakes or at the general pace of the cars, but also to understand, to quantify these quantities, and also to understand why some things happened, and which were also some additional possibilities that teams had available, as I will also show today.
I think one of the things I'm starting to like about Formula One is all the data that's there. But I know that you brought one today. Can we take a look at it?
Yeah, sure. Yeah, for sure. It's a data-driven sport in which data are needed to perform well and also to continuously improve the performance. And for this purpose, I prepared an analysis using the exploratory data analysis software JUMP, which allows us to analyze Formula One data easily and in a quick way, as I will show you later. So in this analysis, I analyzed the 2023 Mexico Grand Prix concerning the pace of the various drivers and the various cars. In particular, I wanted to assess the impact that the tire life had on lap times. So tire life just means how many laps were driven on that specific tire. Okay, so as the tire does more and more laps, we expect its performance to decrease. So it provides less grip and the car becomes slower as a consequence. However, how old is the tire is not the only driver of performance. There is another very significant driver of performance, which is the amount of fuel that the car has on any given lap. In Formula One, nowadays, there is no refueling. So cars start the race with around 100 kilos of fuel on board. And as the laps go by, this fuel gets burned. And towards the end of the race, the cars are much lighter and are able to perform much better. So this is interesting because these two factors are sort of compensating each other, because as more laps are done on a given tire set, the tire gets more worn out, so it provides less performance, but the car also has less fuel, so it will be performing better due to that. So these two factors can sort of even out, and so we must look at each one separately. So in this plot, you have going from left to the right, that the tire gets older, okay, and this decreases performance, but also we have 5 different rows, each relative to a different segment of the race, from the very first laps to the middle part of the race to the very last laps, in which, of course, the fuel load was much lower. In fact, we can also notice that as we go from the first row to the last row, the points tend to move farther down, which means that the performance improves. In fact, you can see that on the y-axis, you have the lap time expressed in seconds.
Okay, so one question here. I know there was a red flag in this race, and you put it where it was, but why is there no data around that? Have you done some kind of filtering?
Yeah, we can say that at lap 32, Magnussen crashed, and so this created basically a race divided in two halves, okay? Before the red flag and after the red flag. Of course, around the red flag, the laps were not representative because
Right,
they
okay,
were
yeah, that
under
makes
the
sense.
safety car, or drivers were pitting as a result of it. So these points have been excluded, and I will also show you how to exclude these points and the rationale behind it by using jump, which makes this pretty easy. So this is the graph builder window of jump, which allows us to create almost any type of graph you might imagine using our dataset. And I will use it to recreate that plot I showed you previously. So first thing first, we are interested in analyzing the lap time in seconds. So I'm going to plot this on our vertical axis. We notice that the bulk of the laps are between 80 and 90 seconds, so under a minute and 30, but we also have a significant number of laps which are relative to much higher lap times, okay? So these points tell a different story compared to this big part of the distribution. So we want to investigate the lap time in seconds as a function of how old was the tire, okay? And we get this sort of graph. We notice that there is not the trend that we have here is not the one that we expected, because we would expect the lap time in seconds to increase as the tire age increases, right? So instead, in this case, we notice a different trend. This, however, is impacted by all these outliers. So they might be outliers, or they might be points which are not representative, as is the case. So we are going to filter them based on some, let's say, objective conditions, okay? For example, if a driver goes into the pits or drives out of the pits, that lap is not representative because they lose like 20 seconds more by pitting, okay? But this not tells us that the car was in any way slower. So we can and we should exclude those points. We can do this through this local data filter. So first, we are using the pit out time seconds variable, which tells us how many seconds the driver needed to drive out of the pit. We are not interested into any specific value apart from the missing values. So if the pit out time variable is missing for that lap, it means that they did not drive out of the pits. So we are going to select the missing values, okay? And you can notice already that some laps disappeared, but this is not sufficient because we also want to exclude the laps in which the driver drove into the pits. So we are using the specular, the dual variable, which is the pit in time in seconds. And again, we are going to select the missing values. We notice that again, some additional points and laps disappeared because they are not representative. However, not all the laps in which the driver does not pit are representative. For example, in case of a safety car, the driver could, for example, follow the safety car for whole the lap, not pitting, but still their pace will be much worse, okay? Just because the safety car is slowing them down. While instead, this does not tell us that the car was effectively slower in any way. So we are going to add this additional filter. So we are using for that the track status variable. Track status is equal to 1 when the lap is under the green flag, so in normal racing conditions. So we are going to use this slider to just select the data which are relative to a green flag. So basically, that's it. And as we can see, now all the data, as I noticed previously, are in a narrow band of lap time, okay, between 81 and 88 seconds per lap.
But still not really showing us that trend you described in the beginning. Like it's more like moving up and down. It's not very clear.
Yeah, exactly. So even though now the laps are all representative, okay, we still don't see that trend. We would expect the lap time in seconds to increase as the tire ages, okay? But we are noticing some wobbling, some local changes, but the global trend is around flat, okay? So as I said, we also must take into account the amount of fuel in this analysis. So we are going to also use the lap number variable to group these laps together to only compare laps which are relative to similar conditions in terms of lap, so in terms of the fuel the car had in any of those laps. So we divide basically the laps in 5 parts, okay? These are the laps from the 2nd to the 16th, so relative to the very first part of the race, where the cars had a lot of fuel, while this last row is instead relative to the last part of the race in which the fuel load was much lower, and so performance was better as a consequence. Again, now the trend becomes a bit clearer because we can notice that there is some sort of upward trend, okay, as the tire becomes older. But still, we are not taking into account the fact that not all tires are the same, because in Formula One, teams can use 3 different compounds. So we are also going to discern the compound used by adding the compound as an overlay by dragging it here. So this is what we are left with. Basically, we have the lap times now divided between their specific tire life, but also the amount of fuel, which is directly correlated with the lap number, okay? But also we have that now the laps are considered separately based on the specific compound which was used. So the soft compound, the medium compound, or the hard compound. Right. So now we have a, let's say, a more global, but also more informative view of what was really happening during the race.
So one thing that really sticks out to me in this data is that some of the subgroups you have some really like narrow variance, but some of the areas, like areas have very much more narrow variance. So especially like lap number 28 to 45, and the short amount of tire life, there's a lot of variance there, but also towards the end of the race, I could see there's more variance. Those 2 areas, probably 2 different reasons, but can we understand those?
Yeah, sure. So even though now all the laps should be representative because they are relative to similar conditions as we filter them, still they might show higher or lower variability depending on which segment of the race they are relative to. For example, in the middle part of the race, like in this part, we notice that the variance is very high, okay? You have a lot of distance between the lower points and the upper points. This is sort of expected because in this part of the race, drivers already started pitting, okay? So some of them pitted around lap 20, some of them around lap 30. So you have this window in which drivers could have very differently worn out tires. Okay, of course, the ones on a newer tire were much quicker than the ones which still had to pit. Okay, so as expected here, the variance is very high. Then here we have the red flag, as you can notice from the points missing as they've been filtered out previously. And after that, we can notice that the variance becomes much lower. So the lap times are now much closer, much more similar to each other, simply because after the restart, during the red flag, the drivers could install the tires they wanted to. Okay, so those who had the new tires installed new tires. All the others installed tires which, even though they were not new, they were very fresh. So after the red flag, tires were, let's say, sort of equalized, okay? So the drivers were now driving in similar conditions concerning performance and tires. We can also notice, as you highlighted, that towards the end of the race, we have, again, increasing variance. This is instead due to the different incentives that different drivers had concerning pushing or not. For example, there were some drivers like Verstappen who were he was first, he had a big gap to second, so he had no incentive to push a lot, risking to spin or have some other problem. So even though he could have been quicker, he decided purposely to be slightly slower and bringing the car home. Instead, there were some drivers, like for example Norris, who were desperately trying to catch up with the front runners, and so they were pushing to the max. So even though in this part of the race all drivers were sort of driving to a target lap time to be quick, but at the same time finish the race with tires in good condition, because this was the fourth, fifth of the race. At the very end, drivers sort of started doing different things based on the place and the gap they had in front and behind them.
Okay. Well, one more question. I think one of the reasons you did this analysis you mentioned was you were expecting like tire life to have an effect on the lap time. But especially you also mentioned that softer compounds will degrade faster. So while on average in the beginning, medium tires will be faster, and then by some point, racers with hard tires will have that benefit of having a harder compound and then have a faster. I'm just not seeing that in your data.
Yeah, this is something that was expected, but didn't really materialize, and it did not surprise us as spectators or fans, but also the teams. For example, Leclerc, after the red flag restart, Leclerc was restarting with an hard compound, while many of his opponents were using a medium compound. He was told by the engineer that, okay, you are slower than others because you are on a harder compound, but wait 5 laps and the medium should become slower than the hard tire. However, this did not materialize, as we can see here, and this is something that also caught out Formula One engineers, which have a lot of data. Okay,
Right.
So we can sort of see this in the data. If you notice, in all the segments of the race, we notice that on average, the medium compound, the yellow line, is almost always below the hard compound. So we see that the behavior was on average slightly better. Okay. At the same time, we even noticed that in some parts of the race, the wear on the medium compound seems to be lower than that on the hard tires. Of course, this is also influenced by the fact that we are considering all the cars, which again had different incentives, and especially we are considering they also mounted the medium or the hard tires in different parts of the race. But still, this highlights the fact that in a track like Mexico, in which tire wear is pretty minimal, the medium tires did not have huge wear, so they were an exceptional racing tire. And at the same time, the hard tires, due to the, as I said, low energy introduced into them due to also the track layout, made these tires not hit properly. Okay, they were still too cold in most parts of the race, and so they never expressed their full potential. And after all, we can see, of course, with the benefit of hindsight, that the medium tire was the best racing tire on average.
Wow, that's super interesting. Well, thank you. I learned a lot about Formula One, and I was impressed with how fast you were able to do that in jump. That was 4 variables you dragged into boxes, and boom, you had that very informative graph. Thank you.
You're welcome. 4 variables, and as you said, it is sufficient to drag and drop variables into the corresponding fields and boxes to do, as I said, exploratory data analysis, so to make sense of what is happening inside the dataset we are looking into. So it's a very quick and straightforward way to make sense of a race, in my case, or a different dataset more in general.
Well, thank you so much for joining me. It's been a pleasure.
For me too. Thanks, Christian.